Hello and welcome to topic 3.2, the product and the quotient rules. So just as a little start, I wanted to go through some derivatives, and just to review, as that's always a good practice, throughout this video I will do some practice problems and I will be proving the product rule and the quotient rule. So to start out with this first derivative, we're going to start out by taking the derivative of both sides. So we have d over dx of f of x is equal to the derivative with respect to x of x cubed minus x minus 1 plus x squared. All right. Now what? Well, we are going to take the derivative. We're going to distribute this derivative. So f prime of x is equal to the derivative of x cubed minus the derivative of x to the power of negative 1 plus the derivative of x squared. So you may remember that the power rule is the derivative of x to the n is equal to n times by x to the n minus 1. So using this, we can now differentiate the following function, and we get 3x squared minus negative 1 x to the negative 2 plus 2x. Well, what are we going to do now? We're going to just simplify this a small bit. So we get 3x squared plus x to the negative 2 plus 2x. And that's our answer. Okay. Next problem. We need to find the derivative with respect to t of h of t. So we have h of t is equal to t squared plus 3t plus e to the t. There we go. Fix that. All right. So we are going to take the derivative of both sides with respect to t. And so we have h prime of t, and we're going to distribute the derivative. So we get d over dt of t squared plus d over dt. And we're going to bring this 3 outside of it. So we're going to get 3d dt of t. And finally, we get plus the derivative with respect to t of e to the t. Well, we now will get h prime of t is going to be the derivative with respect to t of t squared. Bring the power out front. 2 minus 1 is just 1. So we get t plus 3 because the derivative of t with respect to t is just 1. And finally, plus e to the t. Okay, finally, for this last one, my calculus teacher always says do algebra first and then do the calculus. So for g of z, we can simplify this. We can say that this is going to be 3 square roots of z over square root of z plus 2 times by z squared all over the square root of z. Well, then g of z is going to be, well, we can cancel the square roots of z there, so we get 3 plus, and we can just, because we're dividing and they have the same base, this is going to be the same thing as 2 times by z to the squared minus 1/2. So what we are left with here is g of z is 3 plus 2 times by z to the 1 or to the 3/2. Take the derivative of that, so we get g prime of z is equal to the derivative with respect to z of 3 plus 2 times by z to the 3/2. Distribute the derivative. So we are going to get d over dz of 3 plus the d over dz, the derivative with respect to z, and we're just going to say that's going to be 2 times that, so we can get the 2 up front of z to the 3/2. Well, we are going to be left with g prime of 2 is equal to, the derivative of constant is 0, 2 times by 3/2. So we are just going to get 3 times by z to the 1/2. All right. Or also can be rewritten as 3 times the square root of z. All right. Continuing on, we now have 2 new problems that we need to solve. How do we find the derivative of a function multiplied together? And how do we find the derivative of the function that's divided? Well, we're going to start out with the first problem that I mentioned, which is how do we find a derivative of 2 functions multiplied together, such as h of x times by f of x times by g of x? Well, that is a wonderful question. And Leibniz actually kind of struggled with this question at first. But the way that we're going to start thinking about this is we're going to have a little square. And this square, we are going to say that is a parallelogram, not a square. Now you need a square. Also, that was probably not a parallelogram. A rectangle also works. So we have we're going to say that we have a v and a change in v, and a u and our change in u. All right. Well, we're going to now kind of make this into a little box. And if we want to know how the function's changing, what we'll see is that we are going to get u times by the change in v. We are going to get v times by u, but this is just a function. We don't want to know the value of the function. That doesn't help us. And finally, we get v times by the change in u. And then in this final top right box, we get change in u times by change in v. Okay, now what? Well, let's define what are these change in u's actually going to be. Well, since we're not really looking at the derivative, we're just want to know how x is changing, we are going to say that our change in u, if our u is our f of x, is going to be f of x plus a little change in x minus f of x. All right. I kind of want to move all of this over a little, kind of make this a bit easier for later on. Okay, there we go. And now I'm going to move this v over. And the same goes for a change in v. So we are going to get change in v is equal to, well, if v is g of x, it's just going to be g of x plus a change in x minus g of x. Okay, now what do we do? Because we're not really dealing with the derivative here. We're just dealing with the change. Well, if we want to know how this entire rectangle is changing, we need to find the area of these 3 rectangles. So what is that going to be represented as? So we have the change in u, the change in uv is equal to u plus the change in u times by our v. Also, I need to kind of make this a bit more clear. U, and we're going to have a little bar on our v to say change in v plus our change in v. Okay. Now, this gives us our total area, but this doesn't give us the change in the area. If we want our change, we need to subtract off this little bit. So we're going to say minus v times by u. Okay. Now, what if I wanted to know what the average rate of change? So this is telling me what the rate of change is. I mean, not the rate of change, but the change. But if I wanted the average rate of change, what we can do is we can divide both sides by a change in x. So we're going to say change in x and is equal to all of this divided by a change in x. So now simplifying that, we will now get the change in uv over the change in x is equal to, give me one moment. All right, u times by our change in v. Actually, I believe this. So actually what I want to real quickly do is I want to expand this expression out. So we are going to get uv plus u times by the change in v plus our v times by the change in u. All right. And then finally, plus our change in u times by the change in v minus vu all over our change in x, which I'm going to redo that line. Okay, change in x. Well, this uv and this uv cancel. So what we're really left with is the change in uv all over the change in x is equal to the u times by the change in v, and I'm going to kind of separate this out just for a moment, over the change in x. Okay. Plus v times by change of u divided by change in x plus change in u times by change in v all over change in x. Well, what I want to do with this final term is I'm actually going to break this down. And because we can, we're going to say that this is going to be change in change in u times by the change of x. Now, if we want the derivative of this, we can take the limit as change of x approaches 0 on both sides. So what that will leave us with is we are going to be left with the limit, give me one moment. I'd like to specify one other step. So if we want to take the derivative d over dx of u v, well, that's going to be the same thing as the the limit as change in x approaches 0 of the change in uv over the change in x. Well, we know what the change of uv is, so we are going to substitute all of this in for this limit. This is just the normal derivative quotient where we're just saying the derivative this is really just the same thing as f of x plus h minus f of x. All right, so we're now going to expand this out. Give me one moment so I can get a bit more space. So now that I have a bit more space underneath that, we're going to say that we have d over dx of u times by v is equal to the limit as change of x approaches 0, which is really just our h, if we want to think of it like that, of u, oh my gosh, I don't want to zoom, my good sir, u times by the change of v all over change in x plus v times by the change of u all over the change in x, and finally plus the change of u times by the change of v all over change in x. What are we going to do now? Well, we can take these limits. Well, this is going to be the same thing as d over dx of u times v, again, is equal to, and I want to kind of break this limit down into all of its different parts. So we're going to get the limit as change in x approaches 0 of v times by change of, u times by change of v times by change of v all over change in x plus our v times by our change in u all over change in x plus our change in u times by, I want our limit as change in x approaches 0. And once again, the limit as change in x approaches 0, as we're just breaking out the limit using limit properties. Change of x approaches 0 of change in v times by change in u, or rather really our change in u, times by change in v all over change in x. Well, what can we do here? Well, if this change is really just the derivative, we can pull out this u out front, we can pull this v out front, and we can pull out this change in u out front. And that's going to be important in a moment. And I'm going to keep a limit here, what's it called, just for a moment. So we're going to say d over dx of u times by v is equal to u times by the limit as change in x approaches 0 of change in v over change in x plus the limit as change in x approaches 0, and I need a v there, of change in u over change in x plus the limit as the change in x approaches 0 of the change of u times by the limit as change in x approaches 0 of change of v over dx, or over the change in x, not dx. Well, let me highlight for you that this change in u is equal to, if I remember correctly, u we said was, f of x. So we have f of x plus a change of x, all right, minus f of x. Well, if this goes to 0, this is going to just become f of x minus f of x. that is equivalent to 0. So everything right here is going to go to 0. So now let's worry about the rest of this. D over dx of u times by v. This is just, what's it called? The limit as change of x approaches 0 of the change of v over change of x. That's the derivative. This is v prime. This is u times by v prime plus, well, we have a v times by the derivative, as this is the definition of a derivative, of u. So we get is the derivative of u times v is equal to u times by v prime, or sorry, the derivative of the first times the derivative of the second plus the first, plus the second times the derivative of the first. Another equivalent way of saying this is d over dx of u times v is really u, that's a v, I hate working with u and v, times by v prime plus v times by u prime is the same thing as the derivative of the first, which is u in my case, times by the second, plus the first times by the derivative of the second. And that's the way I learned it when I was teaching myself calculus. But that's that for you. And this right here is the product rule. Let's use the product rule in some problems here. So, for this first one, we are going to do d over dx. Well, we will have y prime is equal to, well, we will have the first, so x to the power of 4, times by the derivative of the second, which is e to the x, plus plus the second, which is once again e to the x, times by the derivative of the first, which here is 4x cubed. All right. And that's how we find y prime. The next problem is y is equal to e to the power of x plus 2 and 2 e to the x minus 1. Well, these are just functions here, so we're going to once again be able to apply the power rule. So we're going to take the derivative with respect to x. We get y prime is equal to, well, I'm going to now use my second definition of the derivative. This is actually the one that I'm a lot more comfortable with. The derivative of the first in this case is just e to the x times by the second, which is 2 e to the x minus 1. All right. Plus the first, which is e to the x plus 2, times by the derivative of the second, which is just 2 e to the x. And that would be our answer. Now for this final one, we want to find f prime and f double prime of x. So we're going to, again, apply the derivative, so d over dx of f of x. We are going to find out that this f prime of x is going to be, once again, the derivative of the first, 2x times by the second. The more you say it, the more you will remember it. Plus the first, which is x squared, times by the derivative of the second, which is e to the x. All right. Now how do we find the second derivative? We take the derivative of that again. And this is just the sum of derivatives, so we're just going to say f double prime of x is equal to the derivative of 2x times by e to the x plus the derivative of x squared times by e to the x. All right, this is going to be a mess. So hold on tight. F double prime of x is equal to the derivative of the first, 2 times by the second, e to the x, plus the first, 2x, times by the derivative of the second, which is e to the x, plus Now I have to take the derivative of this part of the function. The derivative of the first, 2x. And here's an interesting thing. We actually already know this value, and we've done it before. And sometimes that does happen. So, we already know that this value here is going to be 2x times by e to the x plus x squared times by e to the x. Now, if I asked you to find the third derivative, that would be an even bigger mess, but I'm not going to ask that of you. So how do we find... So now on to our second part of this video. How do we find the derivative of a function in the form t of x is equal to f of x divided by g of x? All right. This is going to be a doozy. So to start out, we are going to say that our change in... So we are going to define u to be f of x. U is equal to f of x. Our v is g of x. V is equal to g of x. So once again, we're going to start out by finding what we might be able to know. Change of u divided by v. Well, that's going to be the same thing as u plus v, or if we want to know the change in that, we are going to have u plus the change in u over v times by the change in v minus what we don't want, which is u divided by v, as that's just a number that we can't really do much with, and that doesn't tell us anything about how it's changing. Well, what we're going to do is we're going to cross multiply this. So we are going to get v. I'm going to make that clear that that's a v. Times by u plus change in u. All right. Minus our v, or sorry, our u times by v times by change, or sorry, not times, plus change in v. All right. Now what do we do? All over, whenever we cross multiply this, we get v times by v plus change in v. All right. What do we do now? Well, once again, we can recognize that now that we have this like simplified form here, or I suppose the writers of this want me to actually expand this out a little. So we are going to do the change of u divided by v is equal to a bit simplified version of that. Actually, I'm going to keep this up here. So we are... No, I won't have enough space. Never mind. Undo and undo that. All right. Well, we are going to get v times by u. So we are going to get vu plus change in u. That's not... v times by change in u. That way it can remain clear what it's meaning. Minus u times by the v minus u times by change in v. All right. Now what do we do? All right. Well, we have our v times by v plus change of x, or change of v. Well, we are going to cancel what's alike. So all we are left with in the end is v, change in u, minus u, change in v. All over v times by v plus change in v. All right. Now what do we do? Well, if we want to take the derivative, d over dx of u over v, that is going to be the same thing as the limit, once again, using the limit definition, as change in x approaches 0 of the change in u divided by v all over change in x. Change in x is equal to expanding everything out there. We are going to get v, what's it called? Well, I suppose I could probably make this a bit easier for you to understand. So, the way that I'm going to do this is by showing you the process. So we're going to plug in this humongous chunky thing. So we are going to get v change in u divided by change in x minus v change in, or sorry, u change in v over change in x all over v times by v. And I'm going to kind of just restate that this v, or sorry, this change in v rather, change in v, I guess I suppose I could do that up there, is equal to f of x plus a change in h, or sorry, change in x minus f of x. And we're making the limit as the change in x approaches 0. Okay. And this is just the change in v. Alright. So, what do we do with this? Well, let's once again use some of our limit rules. So this is really the same thing as v times by the limit as change in x approaches 0 of change in u over change in x. Apparently, I can't draw a triangle for the life of me. Minus u times by the limit as change in x approaches 0 of change in v over change in x all over the limit as change in x approaches 0 of v times by v plus a change in v. So I want to just start out with this bottom one. So, and I'll start defining what this actually is over here as I slowly walk through this. So, as the change in x approaches 0, as stated up here, this is just going to become f of x minus f of x. So this part right over here is just going to 0. So we get a v squared in the denominator. Okay, interesting. What about the rest of this? So this v is going to stay the same no matter what. But as this limit changes, this is just the derivative of u. So this is a u prime. Minus, well, once again, that u is not, this u is just a constant theoretically. Just kidding, it's not a constant, but it's a function. But it's not dependent on this change of x. But this over here is. This is the derivative with respect to v. So we finally have arrived to our quotient rule. However, I think there's a bit easier of a way saying this. That way it's kind of a bit more in line with the normal or in the product rule. Or at least the way that I learned them both. So I will normally state the quotient rule, u divided by v, is equal to u prime times by v minus, because it's the derivative of the first, times by the second, minus the second, minus the first times by the derivative of the second. And in the end, for me, this is just a bit easier of a way to remember it, as it is quite literally the same as the product rule, except for it's over v and minus. So I have these following functions I'd like us to evaluate. And then after that, I believe we have just one more thing to do. So we have e to the x over 1 minus e to the x. Well, let's use our rules. So take the derivative with respect to x. So we get y prime is equal to, well, we have the derivative of the first, which is e to the x, times by the bottom function, which is 1 minus e to the x, minus, well, we have the top function, which is once again e to the x, times by the derivative of the bottom, which is negative e to the x. All of this is over 1 minus e to the x squared. I don't believe there's anything we can do with that. Maybe if I expand it out, we might be able to see something. Y prime is equal to e to the x minus e to the 2x plus e to the 2x all over 1 minus e to the x squared. Well, all we get looks to be e to the x over 1 minus e to the x squared. Well, you look at that, it did simplify a little. Isn't that nice? Okay. Now, let's work on this next function. So we are going to take the derivative of this with respect to x. Well, we will get f prime of x then is equal to, well, the derivative of the first function, this u, is 0. So it's going to be 0 times by 2x cubed minus 6x squared plus 5 minus the derivative, or minus the top times by the derivative of the bottom. All right, which is going to be 6x squared minus 12x, and don't worry about the constant, all over 2x cubed minus 6x squared plus 5. This is just 0. And I don't think I can factor anything to make this pretty, so we are going to be left with a negative 6x squared plus 12x all over 2x cubed minus 6x squared plus 5 squared. Point 1/2. All right. So find the tangent line and the normal line at the point 1/2 on the function y is equal to 3x over 1 plus 5x squared. All right. Well, let's start. Well, first things first, we need to find the derivative of this function. So y prime in this case is equal to the derivative of the top, 3 times by the bottom, 1 plus 5x squared, minus 3x times by the derivative of the bottom, which is just 10x, all over 1 plus 5x squared squared. All right, now we just have to plug in chug. We want to plug in our x value to be 1, so we get 3 times by 1 minus 5 minus 3 times by 10 all over 1 plus... Is it 1 plus? Oh, I messed up. It's supposed to be plus 5. There we go. That's more like it. There we go. Plus 1 all over 1 plus 1 plus 5 squared. Alright, so let's see. What does this look at 2 come out to be? Well, this up top is going to be 6 times by 3 is 18 minus 30 all over 1 plus 5, that's 6. Square is 36. 30 minus 18 is 12, so that's going to be negative 12 over 36. And then we can factor out a 6 from both of those. So we will get a... Or actually, rather, that is easily simplifiable as negative 1/3. So our slope of our tangent line is negative 1/3. So our y tangent is equal to, and let's make sure that we get all of our points here, 1/2, or y tangent minus 1/2 is equal to negative 1/3 x minus 1. And that's our equation of our tangent line. Our slope of our normal line is the line perpendicular to the tangent line. So it is going to be okay, so it's going to be slope of normal is negative 1 over the slope of the tangent. So we once again just plug and chug. So we will get 3 as our slope of our normal line. So once again, we can use y minus 1/2 is equal to 3 times by x minus 1. All right. And that's our answers. Our y of normal and our y of tangent. Continuing on, this is just a table of all of our differentiation formulas, and I have a problem that I'd like to work. So we have the derivative of a constant is 0. We have a c times by a f, and you take the derivative of that. That's just c times by f prime. F times by g prime is equal to the derivative of the first times by the second plus the first times the derivative of the second. We then have the power rule, which is the derivative of x to the n power is equal to n times by x to the power of n minus 1. Then we have the sum rule, the sum of two functions derivative, which is f prime plus g prime. Then we have the quotient rule, which is the derivative of f over g is f prime times by g minus f times g prime all over g squared. Then we have the derivative of an exponential, which is e to the x, or the derivative of e to the x is e to the x. And then we have the derivative of an exponential, which is ln of a times by a to the x. And then finally, we have the difference quotient, which is f minus g, I mean, not the difference quotient, but the difference of two functions is derivative is f minus g prime is equal to f prime minus g prime. And now we get to use the majority of those rules here. So, for this first one, we will have, we're taking the derivative with respect to x. Looking at this, we have q prime of x is equal to the derivative of e to the x times by x squared plus the derivative, plus e to the x times by the derivative with respect to x of x squared. All right. Now time for adding on to that. So then we have the derivative of a quotient. So we will get the derivative of x cubed times by e to the x minus x cubed times by the derivative of e to the x all over e to the 2x plus 34, or the derivative with respect to x of 34 to the power of x minus the derivative of e to the power of pi to the power of pi. Alright, let's do this. We're almost there. Q prime of x, then the derivative of e to the x is e to the x. So we get e to the x times by x squared plus e to the x times by the derivative of x squared. We bring the power down. 2 minus 1 is x to the first, so just x, plus the derivative of x cubed. That's going to be 3x, 3 minus 1 squared, times by e to the x, minus x cubed times by e to the x. Well, we can just cancel these e's to the x's, and we're going to call this over e to the x for our answer. Then we have plus the natural logarithm of 34 times by 34 to the power of x minus 0. And that there is our derivative. I hope you all found this video informative and enjoyed, and I hope you all will have a great rest of your day.